Across the corporate enterprise today, professionals often mistakenly treat the generative AI interface as a complete, all-in-one execution engine. The standard practice is to take massive documents, transcripts, reports, and conflicting rules, and drop them all into a single text box with a broad instruction to analyze everything. This approach is called one-shot prompting, and it immediately breaks the reasoning capabilities of the system. When you overload a model with multiple objectives, massive context, and ambiguous goals all at once, you force the system to split its processing power across too many competing constraints. This diagram illustrates exactly why that approach fails. When overloaded by a context dump, the AI actually switches its operational goal. It stops trying to find factual truth and optimizes for narrative plausibility, stitching together sentences that sound correct regardless of whether the underlying data supports them. Break down cognitive drift. The model loses track of its logical parameters. It starts missing crucial details, offering incredibly shallow synthesis, and fabricating reasoning to bridge the gaps in its memory. The danger here is that the machine is remarkably good at language. The output it generates will look polished, professional, and authoritative, completely masking the fatal logical errors buried inside the text. In high-stakes financial environments, an obvious error like bad formatting or gibberish text is essentially harmless. A human reviewer sees it instantly and deletes it. A much larger threat comes from hidden factual errors. This is where the AI invents a credible-sounding metric or cites a specific clause that doesn't actually exist in the source material. Catching these requires a reviewer to manually trace every single claim back to its origin. But this table shows the most dangerous category: strategic reasoning failure. This happens when the AI gets the hard facts right, but its economic logic or strategic interpretations are completely flawed. The data is true, but the conclusion is hazardous. Complex professional work cannot survive these hidden failures. If we want reliable outputs, we have to stop trying to write better prompts. We have to completely redesign our analytical workflows from the ground up. To gain actual enterprise productivity, we have to change how we interact with the tool. We are moving the AI away from acting as a reactive, content-generating chatbot and deploying it as a multi-stage reasoning collaborator. This flowchart outlines AI-native workflow architecture through workflow decomposition. Instead of one massive objective, we break analysis into 7 isolated tasks. First is data processing, gathering unstructured inputs, extracting targeted metrics, and structuring raw information into comparative matrices. Only after data is locked in do we move to cognitive phases. The AI analyzes tables for anomalies, then synthesizes a narrative constrained strictly to those verified findings. By forcing the machine to complete and verify one structured stage before it is allowed to move to the next, we strip away the conditions that cause cognitive drift. The reliability of the output is secured through this isolated verification. Even with a decomposed workflow, analysts still face a physical data problem. They have to process massive data sets, like 300-page annual reports or years of lengthy earnings transcripts, which risks triggering a context overload. This progressive context injection diagram shows how to handle large documents. Instead of asking the AI to read the entire report, we use Tier 1, indexing, building a structural hierarchy and metadata map. Analysts then use that map for Tier 2, targeted extraction, isolating specific variables. The AI pulls just those pieces and moves to Tier 3, synthesizing a conclusion based solely on that verified extraction. We apply this exact same step-by-step discipline to the system's logic through sequential prompting. We force the AI to extract data, compare it against a baseline, and then identify anomalies in completely separate, discrete operations. Long context workflows require strict human orchestration. Determining materiality, economic reasoning, and strategic judgment belongs strictly to the professional. To protect that boundary, professionals must adopt the mindset of an aggressive risk reviewer. You cannot passively accept the machine's initial drafts. You have to actively challenge them. This slide details adversarial prompting. You stress test the machine by asking it to identify its weakest assumptions or hunt for ignored contradictory evidence. You also employ confidence calibration, forcing the system to explicitly identify uncertainty, rate confidence levels, and flag missing data. In high-trust environments, professional excellence is defined by the rigor of your analytical skepticism. Success depends on your ability to interrogate machine logic rather than simply producing information. Before any AI-assisted analysis can be used to make a final business decision, it must clear a formal, multi-layered verification protocol. We start at extraction validation, verifying hard data. Layer 2 audits logic. Layer 3 surfaces hidden assumptions. And Layer 4 calibrates incomplete data boundaries. Above all is human accountability. The AI compiles evidence, but strategic execution rests entirely with the human professional. This process applies across every discipline. A research analyst uses the AI to build comparative baselines, but the human interprets the investment implications. A risk auditor uses AI to flag historical inconsistencies, but the human determines the true materiality and decides if an intervention is required. There is one absolute rule for AI-native enterprise workflows. The autonomy of the AI system must never exceed the verification capacity of its human supervisor. AI drafts, humans decide.